Alrighty, we are good to go. Hello, everybody. Thank you for tuning in. And so today we are going to be making some uh, solar flares, basically. These sorts of, I have, actually, here, let's close this. Starting off on a good note, eh? So I posted a tutorial for a star material a little while ago, and some parts of it were okay, some parts of it were not, and I don't like it when my tutorials aren't fully, um, they don't have a great, I don't love it when they don't have a great result, so I'm trying to remedy one bit of that today with these sorts of magnetically charged particle streams, right? You see these sorts of loops that are emanating from the sun material, or the sun surface, and they're looping around and come back in. It looks super cool. Um, Previous attempts that I've had, also on my personal attempts that I haven't really been sharing um, as tutorials, uh, they've been looking pretty good. And here I've got an example right here. Right, like you can see those. They aren't perfect, but I mean they're there. There's the high-res version. You can see they look pretty neat, I think. But on the tutorial, they're there, but they aren't great. So let's try and fix that, and this will be a dedicated tutorial to making these things actually look good. Um, and when you rewatch the tutorial for, because I think I did a good job with the surface material and the atmosphere, so if you're going to rewatch the tutorial, you can basically just replace these sorts of streams that we made in there with these ones that we are going to make today. Alrighty, so let's get started. So these are going to be volumetric, and there's really no way we could do this without using volumetrics, but it's just a simple emission shader, so it's not going to be, hello to who just joined, so they're not going to be super computationally inefficient. They should render relatively quickly. So we're going to start by setting up our default scene. So cycles, GPU compute, that's what we want to use. And we can just leave this default cube here because, well, actually, here, let's do this. Let's add in a UV sphere because that'll more closely match the shape. And then what we can do is we can rotate this on the x-axis 90 degrees. That way these sorts of, I mean, it's not super necessary, but that way these these vertex loops align with the particle loops a little bit better. I don't think it's super necessary, but I like to do it that way. So since we won't be using the bottom half, because that'll be just extra computation and it'll be hidden under the surface material anyway, we can just delete that and connect the bottom as a face. And boom. So this is going to be our shape that we're going to be using. And I'm going to pause here and see if there are any questions. Thank you, moderator. I did make a big goof. Yeah, it turns out you can't share a screen in stage channels, which is something I was unaware of. So we have to use this. You have to use a voice channel, which is not super ideal, but I mean, we'll make use of it. Alright, so we're going to assign a material to this, and let's first start by, in this world node, setting it to black. And we get this, which doesn't look like a flare. That's because it's a surface material, not a complex volume material. Alrighty, so let's start with, let's get started with actually shading this thing, eh? So when we look at our reference, by the way, I just added a texture coordinate node. Got a couple reference pictures here. By the way, always use good reference pictures. It will make it a ton easier, because our mental image of things is often very approximate and not exact, and it can screw some stuff up. You've heard that a million times probably, but I just like to say it whenever I can. Anyways, so we see that we have these sorts of, I mean, they're very, it's rather hard to describe them. They come out of the surface at a small collection of points. It's not a singular point, but it's rather small. And we can see that right here. This is actually a great picture because it shows them in more detail. Well, actually, technically less detail, but it shows the lines clearly. So there's a bunch of lines that come out of like these sorts of clusters of points, and they sort of expand as they get further, and they also get dimmer, by the way, right? So you can see on this left side, they're very bright when they come out, but they get very dim the further they go away from the surface. So they expand, and then they collapse back into a point. And some of them are super huge, so it looks like they just go off the screen and stuff. And well, they do go off the screen, right? But yeah, so let's get started with trying to create these. So the method that we're going to use is we're going to use a special type of gradient texture, and we're going to plug that into the UVs of a noise texture, and you will see clearly once we do that how applicable this will be to what we're trying to do. So first of all, we need to add the gradient texture, and so let's add the gradient texture. We're going to use a special type called the radial gradient texture, and we see this gives us basically, this returns the angle around the certain axis, default to the z-axis that a point is. Right? Let's see if there's any questions. Gotcha. So when we look at a reference, clearly this does not look especially right because this isn't the axis we want to be putting our noise around. And by the way, let's add a noise texture right after this gradient node. And look at this. This is super neat. This is why we're using this gradient texture, because it gives us stuff like this. And the reason why is that it looks like this is because we see that the gradient texture is independent of the distance. The value is independent of the distance away from the center of the axis. And a noise texture is a pseudo-random texture, which means that if it's given an input twice, it will return the same value twice, right? So if the value at, let's say, the center point is, it's fed the value the same closer to the center point as it is very far away, it will look the same, right? So if we're just passing in the angle to this, we can clearly see how something like this would be formed, right? And then this color ramp will increase the contrast, and then you can change the detail, mess with this noise texture quite a bit, right? You can see why we're going to use this, right? Because it's like this is precisely what this sort of magnetic field effect looks like. Now we obviously have to modify it quite a bit, and that's what we're going to start doing right here. So first of all, this gradient texture is on the wrong axis, so let's fix that. So we're going to add in a separate XYZ and then a combined XYZ. And what we can do here is we can shift the axis around, so we can see it's pointing upwards, right? And that's because the blue part of this texture is pointing upwards as well. So if we were to say, so we want them to be centered around these sorts of focal points for all of these all of these edge loops, right? So we want to make the blue texture go, we want to replace this, the green aspect, or the green element of this texture with the blue element of this texture. So we want to plug the Y or the Z into the Y. Actually, sorry, Y into the Z, my bad. X into the Y and Z into the X. You can see that is, look at this. You can see that it's now the texture is centered around this axis, right? And this is what our noise texture looks like. Pretty neat, eh? So now what we're going to need to do is let's plug this instead of into the surface. Let's plug it into the volume. So it still doesn't look that good, and the reason why is because we have these sheets here, and these sheets are frustrating because we can see clearly in our reference these are lines, not sheets. So how do we modify it? And the issue that we're being presented with here is that we only have one dimension, or yeah, we're only feeding one dimension into the noise texture, and that is our gradient texture, right? So we need to add some more additional data to give it a more complex function to work with. So this noise texture, we're going to add in a combine XYZ, which will combine this gradient texture output into the X channel. We can see what that looks like here. And we now need to add in another gradient texture for the Y channel. And the C channel will stay at 0 for now, because we should only need 2 dimensions. So let's get started. So what we need to do is we need to add in some, basically, we can see we want to make this, how would I say it? Here, I'll show you it and then I'll come up with an explanation afterwards. It's kind of how we roll here. So we're going to add in a converter vector math and set this to the length mode and plug this into the Y channel, and we get this. So the question presents itself: why do we do this, and why is this happening? We can see this is clearly closer to what we wanted, right? We need to do some very obvious touch-up work here, right? Because this is pretty much identical to the result we got in the tutorial, and this tutorial didn't really have the greatest result. So what we did here, and the reason why we did this, is that this length node returns basically the radius, it returns the length, the distance to the center of the texture in its most basic form, or center, the location of the object. That's basically how it functions. It returns the distance to the location of the object if this object vector is left untampered with. Really what it does is taking the length of the vector. So if you change this vector in some way, this length output will change as well. And once you get into more advanced sorts of, actually we'll be messing with that later in this tutorial as well. But it'll be less obvious as to the, or more obvious as to the influence that we can have. So what this does, this adds a new component of the vector of the noise texture, and that's this sort of radially symmetric component, right? You can see we're basically just plugging the radius of a circle as a vector input. And then we combine that with the additional data from the gradient texture, you get this, right? It's pretty neat. Alrighty, so how do we transform this into something like this sort of center flare, right? So we need to do a little bit more sneaky vector modification here to sort of shape this how we want, because this looks like a bunch of circles, right? Almost. And clearly our reference doesn't show a bunch of circles, it shows this more intricate shape. So the way we're going to do this is we are going to take this length node and we are going to duplicate it. And basically what we need to do is we need to shrink the output of a certain part of this. Well, we need to shrink. So this gradient texture is going to remain largely unchanged throughout this tutorial. I'm going to, that's sort of, how would I say, it's not really a hint, whatever. That's just some info, a little bit of foreshadowing. But this length node, this aspect of the texture or the vector will need modification. So let's do that. So what we need to do is we need to basically shrink this texture a little bit where it's closer to the center, or where it's closer to this sort of focal point for this radial gradient texture, right? Because we can clearly see that the reason that's not perfect circle is mainly because it's sort of shrunken a bit around that sort of axis, right? So we are going to create a texture that will be basically 0, where there's no x and y components, but it will return the basically, how should I say this? This is kind of difficult to explain with words, so I'm sorry if it sounds a little bit muddy. My descriptions aren't always accurate. Here, I'll show you what we're doing, then I'll explain it afterwards. I think that's going to be generally what we're going to do. So duplicate the separate XYZ, plug the X and Y components into there, and there we go. Alright, so we can see that this basically is going to, if we divide this length by the value that we return from this length, we will get basically the same effect as just shrinking this aspect of the vector by a certain amount. So let's try that. So converter, math, divide, and plug this into the second value. And now let's see what we've done. So this looks a little bit weird, as you can see, but we can change this. So I'm going to use another converter, math, and just simply adding a value to it gives us this, which is really neat. And we can see this is a lot closer to the sort of desired result that we want, right? So another thing that we need to do is, so these, we don't want these values to be shrinking to one point along any axis when that hits the surface. We want it to be sort of into this concentrated area between the, well, we just want them to be sort of being fed into those and emitted out of the concentrate area, the concentrate areas at the ends of each axis. So, and we can clearly see that our gradient texture, it's still very centered around one point. And the way we can do this is we simply just duplicate this add node and mess with the value a little bit. Actually, sorry, we need to, I'm stupid. Alright. Okay, so duplicate this separate and combine XYZ and feed that into there. And what we need to do is we need to take this, actually, we don't need to do this. My bad. I made a mistake here. Okay, so in this, let's see, which one is the z-axis? Okay, so we want to add a certain value to this. Here, let me actually, I haven't checked for questions in a while. looks like there's actually none. Interesting. Right, well, I guess there's only one person that's really listening to this aside from the moderators, so by the way, shout out to you. I wouldn't expect that many questions, but yeah. By the way, moderators, if you're interested in asking questions, go ahead. Alright, so this Z, this output of this Z value, we are going to add a certain value to that, and basically what that will do is it will make sure that this gradient texture will not, it'll sort of go down to a, oh, you'll see what it looks like. So we're going to use an add node, and we can see that we've lost that sort of sharp point there, which is where all the textures were converging, is where the texture was converging. But if we see 0.5 is quite a bit, it's made it a bit too decentralized. So let's change this back to something a little bit more manageable, which I think, let's try 0.05, and boom. Alrighty, so we got the main shape pretty much down. Now we just need to mask out some of these areas because we see it's intersecting with the edges and it still looks a bit weird, right? So also another thing we can do, we can change the scale of this entire thing by adding a vector math scale, and you can see what that does if we change this value. Alright, it's gonna make it smaller, larger. I'm gonna keep that around 2, I think. Maybe actually 3. Yeah. Alrighty. So we have this sort we have this one dimension of this length, or of this vector, and we can see sort of what happens if we isolate that component of the vector. So we can use this pretty easily as a masking tool because we see, well, we can see which areas correspond to which values on the texture, right? So if we take this value, feed it into a math node, or actually, if we take this value, feed it into a math node that I'm going to set to multiply, and then attach a color ramp to it, and flip that color ramp, we can see how we can isolate this one portion of the texture. So we're going to multiply the result of this color ramp with a noise texture. By the way, let's plug in our radial gradient back in. With that, we get rid of most of this sort of most of the rest of this outside stuff that we don't really need. But we need to modify this a little bit more. So we want them to be, as I said, we want them to converge to certain focal points, and there's generally not a whole lot in the center. So I'm going to crush this value a little bit and add a couple sliders back there and dim the center by pushing the leftmost one to black. And then we can just mess with these values a bit. Let's see if we got anything. You can see what each of them do, and I think this looks generally pretty good. Alrighty, next bit. We need to modify the, or we need to dim these bits around as they go further away from the surface. Actually just further away from these focal points. And we can use this length node that we previously made to shrink the thing. We can use that to dim and brighten these values. So we add this add node. I'm going to keep it at 0, but that's just going to be an extra control point. And then connect it up to a power node, and I'm going to set it to like negative 1.0 or something, or 1.3. Just change it until you get a certain mass that you like. And I'm going to add like 0.2 to this, maybe, because you don't want it to be ungodly bright. No. Alright, so you can also add another power here that might concentrate a little bit more. You can see what happens when we use these power nodes. They basically just increase the contrast. They're very useful. Alrighty, so we got this, and that's pretty neat, but also not really what we wanted. So we can change these, we can mess with these until we get what we like. Alright, I'm going to add a little bit more here. There we go. Alrighty. Now I'm going to multiply this by an additional mass that will be, instead of just distance from the focal points, it'll be distance just from the surface in general. So you can take this, combine XYZ, separate out, actually just take this, the output of this add node, and duplicate these 3 nodes and plug that into there and into the multiply, and you'll see what we get. You can mess with this. Pretty neat. And then the second thing we need to do is basically we need to limit the values that we're getting out from these sorts of laterally, or these sorts of horizontal components, right? Because generally we don't see that on these references. It's sort of brightest when it's going perpendicular to the surface. Alrighty, so to do that, we basically just grab this gradient texture and we find the value that corresponds to this vertical component, so, and then subtract that. So in this case it's 0.5, and then we're going to use absolute node, and then plug this into a color ramp, flip it, and control the value so until you get something that you like. I'm going to set this to ease. Then also multiply this by result. And boom. And then we're going to add another multiply node, which will just be general control of the strength of this shader. And we can use this to sort of further control the limits of this texture. And boom. Let's change this to ease. I'm going to add a little bit more there in the center. And then we plug this into an emission shader. And then add in an RGB input to the color. So we want this to be red. Boom. There we go. By the way, I'm going to allow just a little bit of activity in the center So I think that looks a little bit better that way. Maybe actually, nah. It's really a matter of just fine-tuning this to how you like it. Alright, next thing we need to do, we need to alter this noise texture a little bit. So this roughness, it's a bit too much. So we want to have some macro scale details, but we also want to have some micro scale details. So I'm also going to kill this color ramp and instead replace it with a multiply and a power. So let's multiply it by a little bit and add some power to give it contrast. And then duplicate this time with a higher frequency noise and a little bit more roughness. Also duplicate this. Plug that into there and duplicate this multiply and plug that into there. And you can see that looks a little bit better, eh? Maybe you can really fine tune this to how you like it. But that is in essence sort of how I made the noise details for the ones on these flares. Alrighty, next bit, we need to, this is a very mathematically perfect shape, right? It's very well defined. We need to add a little bit of distortion to that, and the way that we are going to do that is to use a noise texture to alter the initial UVs. And the way we are going to do that is by grouping these nodes up and over to the left, and using a separate XYZ to grab the Z component of the vector, adding a noise texture, putting this into the vector. So the thing about a noise texture is if we're adding it to something, let's imagine we're basically adding it to certain points on like a number line, right? We can see that we're always adding a positive value to those points. And so what we need to do to alter vectors, because if we add this to a vector, I want to show you what happens. So if we use a vector math add, and we'll use the color output because the color output's a three-dimensional output. Alright, no questions so far. And I'll use a scale to control the scale. What happens to our end final texture? So let's add this. We can make that a little bit more understandable and turn that into detail. What happens is we can see we're shifting it when we add this, right? So if we equalize this value around 0, right, and we do that by subtracting 0.5 from each dimension, is that we can basically, now what we can do is just scale this, and it won't shift the entire thing over, I'll just distort certain parts of it. So I'm going to change this to like 0.5, and then what I'm also going to do is I'm going to make the strength dependent on the ratio, or not the ratio, what am I saying? The altitude of these rays. So that's why the separate XYZ is necessary, because we have an attribute that works, functions as basically the height info. So we're going to duplicate the scale node and plug that into there. And voila. You can see this bottom is well defined, but this top is a little bit more wavy. Now this is a decent bit of distortion. Actually, probably looks pretty fine. I want to just change the scale of this noise texture a little bit. And boom. Mess with your color. But that's pretty much it. That is, so there's obviously more things that you can do with this, but in essence, this is the concept, right? And you can see the results. I think they speak for themselves. So let me show you what the node group for this star looks like, and you'll see when I open it up, it'll be a little bit more complex, but the principles will be nearly exactly the same thing. And you can basically scatter these things across the surface in the same way that I showed you in the tutorial, the other tutorial. By the way, the surface is actually volumetric, which is pretty neat. So, node groups upon node groups. This is the node group I used for an individual flare. And we can see, actually I'm not sure if I have an example of an individual flare, but you can see the noise textures that we're using. Actually, this isn't a one-for-one replica, but we can see sort of the gradient texture and then the length node. It's pretty neat. Anyways, that is pretty much it for this tutorial. I wish you guys luck in putting this into your various projects, and I hope that this helped you a bit. I tried to explain things conceptually. Hopefully you guys can understand most of what I'm doing. This does take a rather decent prior understanding of nodes to really fully grasp the concept. But yeah. Alrighty. Okay, so Mountain Jew asks, do each corona loops in their own sphere object or isolate them into their own mapping group? So generally, I think I understand your question correctly. So what I do for scattering these across a sphere is, or across the surface of a sun, would be I would basically just, here, let's see if there's, ooh, that's a pretty complex node tree. So here, I'll show you what I did for this one. Let's see. So this right here, this is the group for this entire flare, all these flares, and I did basically do what you're just showing, what you just sent a picture of. This is actually wait, no, this is the wrong material. My bad. There we go. So you can see each of these is a flare cluster, and we have a Voronoi texture that's scattering each of these individual flares across the sphere, and there's some vector math, but I generally combine all of these into one material because doubling up volumetrics is less efficient than just combining them all into one volumetric shader, I think. I actually haven't really benchmarked it, but that's sort of what my prior experience tells me. I might be wrong. But I mean, it's mathematically, it's still the same. It should still be the same if you do it either way. Another way you can do it, and the way I showed in the tutorial, is literally just using a particle system to scatter them across. And that has some distinct benefits, although it's a little bit slower. Namely that you can overlap them a bit easier. With a Voronoi, you'll never get good overlapping texture, right? Like they're always going to be in their individual cells, right? And you have to have a couple of these to get any of that overlap. And with stars, the interesting thing is that there's, like, we can look on our reference, right? There's multiple different scale levels, right? We can see some smaller ones and then some bigger ones. especially like on this one, you can see there's some that like they reach very far into the into just space, and there's ones that are pretty small. So it takes a lot of nodes to do this in one node tree, and I think if you want just pure visual fidelity, particle systems might be the way to go. And you also get more control that way. But this definitely does have its advantages as well. Let's unhide all this. You can see just some material rendering. Yeah, like this method is a little bit faster. Does that answer your question, or did I misinterpret something? By the way, nice render on the right there. Awesome. Ku, thank you for your comment. Alright, so question, won't creating these volumetric particle flares, will it be fairly computationally heavy? Yes, that is the downside. That's the main advantage of doing this all in one shader, like scattering it procedurally with the with Voronoi. But yeah, it will be fairly computationally heavy if you're using multiple different particle systems. Yeah. So I'm using a, the question was, what sort of graphics card am I running? I am using a RTX 2070. So it's I mean, it's not a 30 series graphics card, but it is definitely no slouch. But these volumetrics, an individual flare isn't too bad. And it generally, like, I haven't had render times. Yeah, no, nothing super special. With emission, you don't actually need any high volume steps, which is pretty nice, because the Monte Carlo effect, well, you don't have to do anything with absorption, which is the main reason why you need small sample steps. It'll just take more samples the larger sample steps you have. So you can sort of optimize your performance that way. And once you get pretty good at knowing what to do on what certain, just how to work around volumetrics, you can definitely find good ways to optimize this and tune it to your scenes. Because maybe you have like some sort of spaceship and there's a bunch of like indirect bounce lighting that's super noisy and you need a lot of samples, but so you can afford a little bit of noise and a couple samples on the sun, because you're going to be doing a lot of samples. Or you could have maybe like one of my planet shaders, which isn't very noisy but does take a little bit of time per sample, and you can sort of mimic that with the sun, right? Like just basically making the sun so that you don't need to overdo the samples on the planet shader, and just sort of equalize the load so that you aren't really having any bottlenecks in your renders. I hope that makes sense. Did I explain that well? I need some feedback. Awesome. Alright, so unless there are any other questions, I think I'm going to wrap it up for now. Thank you guys for tuning in, and thank you people in the chat for asking wonderful questions. It's I think I said this before, but one of the reasons why I am now trying to live stream these is because user feedback, or not user feedback, but listener feedback is something that definitely makes these tutorials a bit easier to understand, because I'm not talking directly into a camera with no audience, expecting people to just magically understand what I'm saying. Because I generally tend to be rather incoherent, and I was today, as you can kind of tell. But Yeah, it is. It's a very I've gotten kind of used to it because I've recorded like 10, 12 hours of tutorials, but it never really gets old. Um, Having response to knowing that you're speaking to actual people is really, it really helps a lot. Alrighty, I'm gonna sign off, guys. Thank you for watching. Uh, I hope there's definitely some. I hope you definitely were able to grasp something from this. Um, and I hope that you guys make some really neat result. You get some really neat results from this. So have a good one, guys. You can find links to Discord servers, Patreon, Instagram, that sort of thing, along with PC specs in the description. If you have any questions, either hop on the Discord server or just post them in the comments. I'll try to respond. And I will see you guys later. Have a good one.